Hi, this video is about Docker. It will explain in simple terms what Docker is, what Docker images are, what are containers, and Docker commands that will help you work with images and containers. So let's get started. So what is Docker? Docker is an open source containerization platform. In simple terms, it's a way to bundle your project into one single file, and that file is called Docker image. Now, if you are used to Java projects, you would have been used to packaging your Java projects as a jar file or a war file. Similarly, in Docker, you bundle or package your application into a file called as Docker image. You can create an instance of this image into standardized units called as containers. So containers are nothing but a running instance of the Docker image. Containers have everything the software needs to run, and that includes application source code with operating system libraries and dependencies required to run the code in any environment. Now let's try to understand what image consists of. Image is nothing but a set of files within the file system needed to run your application. Now let's assume you want to run a Java application. So what all things would you require? You'd need a JDK or a JRE to run the Java application. You would also need the dependent libraries that the application depends on. And obviously you would need the application jar itself. So if you package all these within your file system, you can easily run your Java application. In fact, you can take all these set of files and run your application anywhere you want because you have all the required files within your file system. The image also contains something called as the command, which runs when the container starts up. In this case, our Java application, the command can be java-cp app.jar. So essentially, when the container is coming up, the Java process would start executing using this command. So image consists of file system as well as the command that is needed to start the Docker container. Now let's try to visually understand what happens within the container when you start the instance of an image. The files contained in the file system would get copied over to a segment of the hard disk known as namespace. And then the command specified in the image would get fired so that the process starts within the container. Now when the process starts running, we say that the container is running. The process interacts with the operating system kernel and uses the shared resources such as RAM, network, and CPU. So this is what a container basically is, a running instance of an image. Note that the container would be running as long as the process running within the container is running. The moment the process exits, the container would die. Moving on to installation, we can install Docker Desktop to run the Docker commands to play with the images and the containers. As you see here, there are links to install the Docker Desktop depending on whether you are on Windows or Mac OS. I have included these links in the description of the video. I have installed the Docker Desktop on my Windows system and I have started Windows Terminal. Now the command to list the images is Docker images. It will list all the Docker images present on your local system. If you see the columns, there's an image ID column. Image ID is nothing but the first 12 characters that uniquely identify this image. It has a repository column, which is the repository where the image would be pushed or where it was pulled from. The tag represents the tag that was used on the image to upload to the registry. There are more columns like when it was created and the size of the image. Now let's say if you want to download a new image, you can use docker pull command for that. Now I am using a famous image called BusyBox, which basically contains a set of Unix utilities that you use in your day-to-day life. So when you do Docker pull busybox, you will see that since you didn't provide any tag, it will use the default latest tag to pull the image. Now it's trying to fetch the busybox image from the repository into your local file system. Now it has downloaded the image. Now if we run again the docker images command, you'll see busybox is listed with the latest tag. It was downloaded with the image ID of this. It has a size of 1.24 megabytes. Now, given that we have an image, how do we run this image to start the container? So to demonstrate that, I have created an image called as microservice1, which is a Java Spring Boot application with a tag of 001-snapshot. Let's try running this image. The command for that is docker run and then the image with the tag. So I'll have microservice1 colon 001-snapshot. And when I do that, you'll see that the Java process starts executing and the container is coming up. So it says that the Java application has started. Now this command didn't exit, so the container is still running. If we go to another tab and do docker ps, which basically lists all the running containers, we'll see that the container is running with the image microservice1 with the given tag. The command that is executing is /cnb process web. Now if I press Ctrl C to exit this, you'll see that the process has exited and the container died. Now if I do again docker ps, it will not list the process that was running. However, if I do docker ps dash dash all, it will list the microservice one container that was exited a few moments back. So docker ps dash dash all lists all the containers that ever existed, even the exited ones. Now you may ask, how do we remove the stopped containers? Let's say you have a lot of stopped containers and you want to remove all of them. So the command to do that is docker system prune. Now it will provide you with a warning saying this will remove all stopped containers, all networks not used by at least one container, all the dangling images, and all dangling build cache. So if you are okay with all of these, go ahead and hit yes, and it will go and clean all the stopped containers and the images. The docker run command has another variation wherein you can pass a command after the image argument. What this essentially means is this new command will override the command that existed within the image. So when the container comes up, the command that would run for the process is the new command passed in the terminal and not the command that was part of the image. Another thing to note is docker run command runs two commands behind the scenes, docker create and docker start. What docker create does is basically sets up the file system needed for the container. And docker start basically starts running the command that was specified within the image. Now to confirm this, let's try the same example that we took for the Java application. When we had run the docker run microservice one, the Java process had started. Now let's try it as a two-step process, first with docker create and then docker start. Now again, to list all the images, we have the microservice one image. Now let's try docker create with that. I'll say docker create microservice one colon 001 snapshot, which is the tag. So if you see, it didn't start the Java process. Instead, it spitted out some string which identifies the container. So if we do docker ps, there's no process or the container that is running at the moment. Now when we run docker start and then the unique string that was pasted on the command, Now the Java process has indeed started running. This is same as what we had got when we had run the docker run command. You see the Java process has started now. So this confirms that docker run basically is a set of two processes, the one created with docker create and then docker start. Now that we have a running container, let's say we want to manually stop this container. Let's see how to do that. First, let's print out the ID of the running container using docker ps. We see that this container is running. Now to stop this container, we say docker stop and then the container ID. So this has stopped the running container. If we run docker ps again, you won't see that container again. So what docker stop command does is it sends a sig term to the running process, allowing it time for the cleanup. Now, if you want to kill the process immediately without giving it time to even for cleanup, docker kill is the command. So let's say we again run the same microservice one and let it start running. So instead of, let's first get the ID, and instead of stop, we can say docker kill and then the ID of the running container. This would kill the process immediately, whereas stop would give some time for it, allowing it for some cleanup activities. Now let's say you have some stopped container and you want to start it again. The command to do that is docker start dash a and then the ID of the stopped container. So in this case we see two of them. Let's pick the first one and then it will start running the container again. So this is how you restart a stopped container. Note that once a container is stopped, the data that was present in the file system would remain intact. So once you restart the container again, you would still find that data within the file system. Now let's say you want to see the logs of the running container. So the command to do that is docker logs and the container ID of the running container. So this would spit out the logs from the container onto the console. Now let's say you want to go inside the container and inspect the file system, similar to doing an SSH on a remote Linux machine. So the way to do that is using docker exec -it command, where you pass in the container ID and the command, let's say sh. So now it presents us with a prompt. Now we are actually inside the container. If we do ls-l, these are all the files, set of files that are present within the container. If we do ps-ef to see the processes running, we see that there's a Java process that is running, which confirms that we are inside the container which runs the image microservice one. Let's say we want to remove an image from a local file system. The command to do that is docker rmi, which stands for remove image, and then we can give the ID of the image like so. This will remove the image from your local file system. See, it deleted all the layers that were part of the image. Now that we have seen about images and containers, let's learn how to create our own image. For that, we need something called as a Dockerfile. This is a Dockerfile to create an image for a Redis server. Every Dockerfile consists of instructions which depicts what the image would consist of. Typically, a Dockerfile would start with an existing Docker image as a base and then build on top of it. In this case, the first instruction we have is from, and it says from the base image Alpine. Now, Alpine is a very lightweight Linux distribution which we can use and install stuff that we need on top of that. Alpine is very lightweight, it's around 5 megabytes in size. It comes with a package manager APK which we can use to install anything that we need on top of it. The next set of instructions is run. which basically runs the command apk to install Redis on top of Alpine. And finally, we have the command which would start executing when the container is coming up. Now that we have this Docker file, let's create an image out of it. The way to do that is docker build dot. Now dot is the build context here. What this means is when we run this command, Docker daemon would look for a file called Dockerfile within the directory provided, which is dot, which is the present working directory in this case. Now when we run this command, you see that it will first try to download the Alpine image because we had selected that as our base image. Now once it has downloaded, it will start installing Redis on top of that. So here you see the first step, it downloaded Alpine and it created a file system, basically a snapshot, a layer out of that. Once it has that layer, next step, it tries to install Redis on top of that. And once installed, it has another layer which it exports to create the final image, and the final image has the ID starting with C7 to AF8 and so on. Now that we have our image created, let's confirm it with the docker images command. So here you see the image ID created, which we created from the Docker file. If you would have noticed, the image that is created is without a tag and a repository. It says none for both these columns. So if we want to tag the image while creation, we can run the command docker build -t for tagging, and then we can provide whatever the registry is that we have, docker, then the image name my Redis just for namesake, and then the tag that we have. For now I'll give the latest, and then the build context, which is the current directory. So it will build the image with the repository and a tag this time, and we'll confirm that in a minute. Now if we run docker images, we see that the image created is with the repository and the latest tag. As we saw, the Docker build creates layers on top of other layers and finally creates image out of all those layers. Now let's say you want to do the reverse. You have an existing image and you want to see or inspect what all layers were ever created during the build process. Now the command to do that is docker history. You can specify the ID after the history command, and it will give you a gist of what all layers ever existed while the build process for this image. If you see, there are 4 layers mentioned here. The first one is the Alpine image which it downloaded, and the size was around 5.59 megabytes. Then the next layer was for the command for the Alpine image. The next is the run instruction where we installed the Redis on top of the Alpine. It added around 4.7 megabytes on top of what Alpine already had. And the last layer was adding the command which is used while the container comes up. So this history command gives you a useful insight and what each layer is made up of and how much size it added on top of the other layer. Let's do a quick recap of what we have seen so far. At first, we saw listing of images using docker images command, which lists all the image present in your local system. Next, we saw how to run a container using docker run image command. We saw another variant of that where we can pass in our own command which would override the command that exists within the image. Next, we saw how docker run is a two-step process of first docker create and then docker start. Next, we saw how to list running containers using docker ps and docker ps -- all, where the latter would also print the stop containers. Next, we saw how to stop containers using docker stop and docker kill command. We also saw how to restart stopped container using docker start command. Next, we saw how to take a look at the logs of the running container using docker logs command. Next, we saw how to remove all the stopped containers from the system using docker system prune command. Next, we saw how to execute additional commands inside the container using docker exec-it command. Next, we saw how to create our own Docker file and the build process during our own image creation. Next, we saw how to tag an image. And lastly, we saw Docker history command where it showed different layers that were created during the build process. So that's all I had in this Docker simplified video. It's just the tip of the iceberg. There are a lot more concepts within Docker which is not covered as part of this video. But hopefully this will give you a base and the comfort level to start exploring all those advanced Docker features. Hope you liked this video. Thanks for watching.